So we're taking a look at this crack on the T-slot on the, well, I don't know what we're calling that, the saddle. Basically we've drilled and tapped for an M6, which is a nearest diameter quarter 20, and that goes in to just short of this T-slot so it doesn't go through, and it's closed up the gap. So I'm not looking at trying to make it as good as new, but if nothing else, it's a visual reminder not to put a T-nut there and crank raunch on it. It's a shame the guy who had it before didn't do that. For those of you who've been following this restoration, there's a chap called Steve Summers has just put up his final video in a sequence about rebuilding the compound slide on his Cincinnati 24-inch shaper, and he's had to make a new tapered gib for it, which most of which he's done actually on the shaper. Done a smashing job, and yeah, well worth a trip over. I'll try and put a link in below. So if you're watching, Steve and your wife, all the best. I've got number 2 dog here today, supervising in the best way possible by basically sitting in right in the middle of the gangway. And number 1's monitoring chicken progress. We're having a bit of a clear round. Next job is I've got to decide whether I'm going to put a set of wipers along this face, which is on the vertical face of the slide, front slide. I've also got to set the clamp plate which sits under here, but before I go about doing that, I've still got to lots of still got tos. I'm going to uncover the slides that are scraped on here, and then I need to get rid of that section which was, I think from memory, that end where it goes out, the last 4 inches are a thou wider, but I couldn't determine how that, what was that being caused by. So I'm going to strip off the masking tape now, take another couple of prints and see if I can work out what's afoot. But yeah, I mean, 1,000's not a huge amount for me to worry about in the scheme of things, but I'd like to get that bit right. Then that section is near as damn it completed. I can start looking at rebuilding that, and in order to rebuild it I need that finished. So I need to decide if I'm going to put on a pair of wipers on here, which is no big shakes to do, but it's just another job drilling it and tapping it. I might just drill and tap and put a couple of blanking fixings in and worry about the actual wiper section later. These are obviously already done. I've then got to readdress, as I say, the clamp plate and the spacing on that to there, and I'll take a look at the gib strip that sits in here, because both of which were pretty well, that one was worn and that one was bananaed from what I recall. The other thing was, whilst I've got it on the bench, there's no facility on this shaper for rotating the box. The box itself has got a key strip which picks up on the top, and then basically a big long set of these T-bolts that slide in and clamp right through to the front of the box. So I'm assuming that it was the lower end spec model. The next one up got the rotation option. The box itself has got a nice big round opening on it. So what I'm wondering now is, do I, whilst I've got this on the bench, make up some kind of facility so that at a later date I might modify it so I can rotate it, and if I do modify it so I can rotate it and do a 50-degree dovetail, which is what I struggled on that. So a few things for me to think about. There's not a huge amount of material to go at, but if I'm going to do it, now's the time to get it drilled and so maybe some studs set in there. So I'll probably have a think of that and put some sketches together. I might even put up the ideas and see what you chaps think. Enough of me babbling on. Well, we took another look at the width, measured it and decided that it was actually 1.5 thou taper from the left hand side to the right hand side as you're looking at the front of the machine. So having taken the taper out, we've just re-established the bearing surface. It's probably not 20 points per inch, it's probably closer to 12, but as we've said before, this thing's only indexing bloody slowly and not very far at that. So there's good bearing contact and there's plenty of space for oil, so I'm pretty okay with that. So we're now looking at this angled face in relation to that, so the overall angle, and we want to come down a little bit on the top edge, and then the gap between the clamping plate and the width, we've currently got 5 thou gap measured with feeler gauges, and I want to take that down by a couple of thou, so 3, one lead 2 thou. So basically that surface there and that surface there, I want to come down by 2 to 3 thou, and I really want just a smidgen, say if that's 3, that would be 2.5. So I'm going to probably do it with a draw file in it, once I get it roughly down measured, and then I'll have a look at either lapping it or scraping it. I'll measure the depth with a Mitutoyo depth mic basically across the gap, and there's a consistent 5 thou end to end, so we'll see how inconsistent it is when I'm done. Well, that's took about 45 minutes settling. See if we can get you a shot of the angle. So the angle's nice and parallel, well that clamping face is parallel with that now, and I've got 0.05 of a millimetre gap, which is 2 thou. That's just with me pulling that up to that edge. Under gravity it'd probably be slightly bigger, but it slides nice. No grinding noises like we had originally. So happy that that bit's done now. Need to look at the Gib strip there, which is the one that fits at the back side of this here. So that's the next thing. So I'm going to spin this assembly around and see what I can do then. Well, we just started rough scraping the Gib, which sits at the back of the box channel to hold the workbox in place. It wasn't scraped before. It's a piece of steel. It was bent like a banana, and well, I wanted to peen it, but not knowing how to peen, I've basically bent it back to something like. So I've just started scraping it. Being steel, it scrapes differently. It's the first time I've done any steel. So you can see that's the rough scrape, just to pick up ink, and now I'm starting to work the ends in. The scraping's a bit nasty. You can see where it starts to dig in, and then you get a deep groove. It's not actually, I don't think it's the blade that's doing it, I think it's the swarf. One of the issues is you get shards of steel coming off. You can just see them on these gloves, and they're like little needles. So rubbing my fingers over it is well, I've learnt that lesson, let's say. So I scrape, then I go over it with an old file to knock off the worst of the burrs, then go over it with a diamond stone to take the burrs down, and then I go round fastidiously and do the edge, because as the scrape is going over the edge, it's leaving little points of steel swarf. Slow progress. It's I can see why guys prefer doing cast iron. So that's the swarf you're getting off, and unlike the sort of dusty small chips you get from cast iron, these is sharp. You know, I'll get a couple more cycles in and then I'll try and set you up on an overhead. It's significantly harder to scrape because it's harder material, but as your scraper's moving across your previous line of scrapes, you can feel it go in and out of every scrape line that you've done. Now I know that the sharpening angle of the scraper is supposed to be different. I haven't tested that yet, not least because I'm down to my last tip, and they're 30 quid a piece. Working on a budget here. Anyway, there we go. Well, it's a bit of progress. Yeah, sort of 2/3 of it contacting now. It's quite a light inking, as you can tell from the print. Still just removing all the blue till we get this dead spot in the middle covered, and probably that's been covered, but as I've dropped that down, the next bit's coming. The hinging's not quite there either. It's still hinging towards this end and on that end. So I want it hinging to show that it's a flat plane, and then we'll look for some sort of count. Besides which, it appears it's lunchtime, as my chef's come in to tell me such. You can hear it going through the scrape lines from the previous opposite direction. Been watching a guy on YouTube, I'm not sure where he's based. His channel's Shaper Andy, that's A-N-D-I, and it's the first time I've seen somebody cutting T-slots with a shaper. He's got two shapers, I think. One seems to be around about 14-inch stroke, the other one looks to be a much bigger one, over 20. But he's doing some interesting work on there, made up some nice machining fixtures, and I've only just started working my way through his videos, but well worth a trip over. Shaper Andy. Anyway, my dusty brush is getting a bit threadbare. You can see the burrs down the side of that. They are razor sharp. Not really filing it, as rubbing it off down the edge, but it wouldn't do it with the edge of the diamond stone. Well, it would, but it took significantly longer. I mean, it's questionable whether it actually needs a scrape finish on it, but I was just concerned that it was pretty badly bent, so I figured, what the hell, I've never done steel, I'll apply what I've learnt on the cast iron and try it. And yeah, it scrapes. A lot more effort involved, and I might actually see if I can get a measurement of the depth of the scrapes, because I'd be surprised if they're as deep as they are with cast iron, even though I'm putting in more effort to do it. Yeah, you only rub your finger down it once without deburring it. It's like going over the back of a porcupine, I should imagine. There's a burr somewhere around here, I can feel it when I'm moving it on the plate. And that does seem to be the main problem with doing steel. And there's no point in scraping it until I've got a reliable print. Can't feel a thing. As I've said before, that's my duff finger, so it helps to rub it with one that's got some nerves still living in it. Should get a print off that. Huh? So, not much of this you can see. It's a bit heavy in there. It's still hinging towards the ends, and this end's hinging better, so it's probably around that. So we'll just go carry on and keep taking the blue off. One day I'm going to try and get these jaws off and replace them with some aluminium ones. Only I've tried and I can't break the screws loose. Hear the force, and you can actually smell the heat generated by the blade. You know, when you're cutting on a lathe and you can smell it getting hot before you put cutting oil on, all the suds. And my understanding, when you difference between a cutting angle on a turning bit between steel and cast iron is cast iron is a much more robust blade, so steel might be pointed looking at it from the side. If that's the top, steel might be like that and cast iron might be like that. So assuming it follows the same principle for scraper blade, this is due for a scrape by the feel, a sharpen by the feel of it. So I'm going to give it a more acute angle, make the blade more pointy, and see if it changes the way it handles. I mean, we're moving material. It's not in a very controlled manner though. Nasty little sharp things. I'm not using any lube either with the diamond stone, whereas with cast iron I use a bit of white spirit. This seems to be cutting all right without clogging. And I appreciate I've rolled the edge probably 32nd of an inch or a mil or so, but I'm not that fussed about that, because it's going to be infinitely better than it was. Very much a fitness for purpose approach, and this will fit my purpose. Right, well, I've set up a different angle because the previous sequence you're too far away to see what I'm showing you. So excuse the jaunty position, but I want to try and get you to see the difference in it is significantly harder than doing cast iron. I mean, I am putting a hell of a lot of force into that tip to get it to take a shaving. Leaning on it, as they say. And what I've found is the first cycle, which, I mean, I seem to do it differently to what I've seen recommended, in so much as I'll go that way first, then before doing anything else I'll turn and go that way. So when I'm roughing, so I'm actually getting effectively 2 passes per print. But the downside is you're not deburring between these changes in directions, and I think that makes the whole thing a little bit more chattery. Or I could be talking bollocks. Now normally at this stage I'd run my fingers over and go, oh yeah, lovely that. Only what that usually ends up doing is making my finger look like a pin cushion. Look. I don't know whether you can see these, like little bloody needles. So we're slowly extending towards the middle. Still got, what, 1.5 inches. Big hole over there, but certainly beginning to get more of a flat plane. So I'll probably not video the rest until we get to finish scraping. It's all much of a muchness. I'm happy to call that done. I could spend more time refining it, but for what it's doing, I think that's much better than it was, and almost acceptable as it could have been. I know this section looks low, but it's had one one scrape since the last one, at which point it was the highest point. So it's no more than 3/10 out. I'm looking at Focus. Looking at it, it's not bloody far off. I'm happy with that. Job's a good one. Well, if I'm any judge, this should be the last print. I've marked the end, I don't know whether you can see that, 3 scrape marks, because I want a consistent print. So that end goes down first. Excuse the fly buzzing about. And then we do rotation test. It's about there. About there. I'm only pinching the one end because I don't want to put a load of weight on it. You see that? Marvellous. Might even do a spot count on that, see how many there is. And there's a bit of variation from 19, 13, 20, 20, 12. So I'm happy it's alright. I mean, it's probably only 30% of contact area, but it won't take much use before those peaks are dropped down. I mean, for example, if I went over it with the diamond stone for 2-3 minutes, you'd get much bigger surface contact area. Probably might even get slightly more contact points. But I'm happy with that. Job's a good one. Moving on. We're just starting to build the carriage back up. I got the height adjust screw cleaned up, oiled up, put back into position. I've had the gears on and the adjusting handle connected, but there's quite a bit of damage to the teeth of the gears. They've had obviously chips go through them. Regardless, people have carried on cranking it. So it works, but it was a bit chewy. So I've basically hand filed off the worst of the burrs, or the high spots, let's say, on the working faces. That was a pretty bad one, and that one. So I put it back together now, and I mean, in fairness, I haven't had grease on it yet, so that'll smooth it a bit. But I wanted to get the worst of the. I was hoping putting it on and winding it round twice would polish up the high spots, but it didn't. But yeah, every piece on this machine's got a part number on it. I wonder if they're still carrying spares somewhere. That's a lot less crunchy. Tiny bit of grease on this. It's still not as smooth as I'd like it, but at the end of the day, it's fit for purpose. Could do with some decent grease, I think. Yeah, so next job's to get the lead screw in, which I think is going to be tomorrow. It's like a coiled spring ready to go off. We're going for a walk, Sky. You want to go for a walk? You're going to go and find your lead? Gotta look at it. So keen. Anyway, I'm happy. Well, we've been trying to get out the retaining screw that holds the clapper box to the slide. I've basically drilled right the way through it with an 8.5mm drill, and then tapped it from this end right the way through with an M8.5, with an M10, then wound in a fully threaded cap head until it bottomed out on the underside of the screw. And I'm now basically, as I tighten the cap head, it's releasing the screw, but it is damn tight. So there's obviously something knackered with the threads. I'll bring you back when I got it out. So that's the retaining screw. So you can see my thread down the middle of it. You can see the tiny little slot. Now I've ended up using an M10 in that with an Allen key, full wrench, and whacking it with a lump hammer just to get it to shift. And the threads are clean. That face is a bit snotty. The clapper box where it fits, it's not really rusty there. Now the threads that it went into are a bit snotty and seem quite blunt. So anyway, I've got it out. That's the key thing. I can now work on that without too much trouble. I've now got the problem of getting the cap head out of that, and then in order to tighten it back up, what I was thinking of doing was basically take this cap head out from this end, machine a rebate into that, and sink the cap head in to the head, and then if I'm feeling enthusiastic, blob a weld around the underside so that cap head then becomes part of that. Might even weld the top as well and then flush it all off. So yeah, got to get it out first, or turn it out, one or the other. Probably try and grip it somehow. I mumble on. Did I mention I can't weld very well? Anyway, we've just got to spin it up in the lathe and clean off the crap. Working on the basis of if that Allen head comes loose, I can wind the nut out, or wind that cap head out from this side, and then basically flip it over and stick it in from the other side and achieve the same result. It'll be a bit of a pain in the arse because I'll have to take the lead screw out of the head, I think, to get at it. Anyway, infinitely better than what it was, and I'm not entirely sure why I'll need to take it off, but once I've set that box so it'll rotate, it should be sorted. So yeah, welding, a lost art, certainly in my workshop. Well, it ain't pretty, but I think it'll be functional. It's got it where it's got. Not pretty. Anyway, just trying to establish why it's all locked up, and it looks to me as if the shoulder length is a fraction under where it should be, because there's a definite drop below this surface, and if it's supposed to be a tight joint, it should be, well, if it's not got to be loosened, I would have said it's got to be flush or slightly proud. Anyway, it's pick it up, but that shoulder there, the largest one's ground by the look of it. Anyway, a bit more fettling up, but as I'm going to lap this or scrape it to make sure it's flat, because I don't think it is, I can mess about with the shoulder length later. I've been doing a Tom Lipton. That was the rusty handle. We're just gradually cleaning it up. It appears to be cast iron, and it was I think nickel plated. Anyway, the plating was best part flaking off, and the rust pitting was quite a few thou deep. So I spent the first hour just going over it with a medium cut file, then a fine cut file, and then working through 80, 100, 120 grit. Yeah, still wants a bit of work. But getting nice. It's a lot nicer in the hand now than the rough arse piece it was. Anyway, it's tea time. Just taking a look at the machine box. So this is that's the face that the vice would sit on. That's the key which picks up on the saddle. And if you remember, I was, or if I included it in an earlier part, I'm looking at how I can get this to rotate, because at the moment it's keyed so that it goes on and it stays straight. What I'd like to do is clean up the bore on this rough casting, front and back, to give me a size, no matter what it is, but a size. And then the inside face as well, which is rough cast. I'd like that machined inside and out. Then I've got the basis of a mounting position from which I could then build something. Do you like that? It's a Tom Lipton sketch. So saddle on the end which clamps onto the cross slide, and then rather than drilling a load of new holes into that, make an adapter plate up about an inch thick, which would clamp to the existing T-slots on the saddle. In that adapter plate there'll be a series of holes. I haven't decided yet whether it'd be a series around the PCD or just a centre hole with a bloody great big nut on it. But that would then clamp this piece, which would fit on the inside. For those of you paying attention, you think I've got to work out how I'd have to make that in 2 pieces so that you can physically get it in. I was going really well up until that point, and then I decided, well, 2 pieces would be easy. But if it's got a central bolt through, say something like inch square, sorry, inch diameter, or even bigger, 30mm. As that was clamped up, providing I got that shoulder length right and that as a machined face, this outside face is already machined. As it pulled up tight, it would clamp the box to the adapter plate to the saddle, which then leaves me with, I need some means of providing a support at the outside end. So if I'd machined both sections, I could do basically a duplicate of that running this way out to give me a central pivot point, which I could bring down to a foot mounted on the section there. Well, that's what I'm thinking. The benefits of doing it that way is I'm not actually changing the machine substantially from original, other than machining these 1, 2, 3, 4 surfaces. Now I can work out how to machine those, and I think I could do that with a boring head in the horizontal arbor mounted on my mill. But what I can't work out is how I would machine what I would believe to be the important clamping faces, because my boring head, to adjust the diameter, you have to stop everything, put a socket head in, open it up a thou or two, and do again. So it's doable, but whenever I've tried to do like a facing cut, what I've ended up with is just a series of little ridges. I mean, it'd be ideal doing on a lathe on a faceplate, apart from it being a bit big. Be a nice one for A-bomb on his Monarch. But what are we talking? 10" by 10" cube. It's way too big for my lathe. Anyway, there you go. Just musing on another idea. The top one's a box off a different shaper. It's only the box, so there's no saddle or anything. Obviously the whole space, because it's a bigger box, it's about an inch bigger all round, the T-slots won't line up and all the rest of it, but it's a bigger footprint box. It might prove beneficial to have that mounted rather than the smaller one. Same thing applies on that. There's no facility for rotating it. There's the same 2 holes. I mean, for all intents and purposes, it looks like it's off the next size up Elliot unit. I'm just musing on, is it worth doing anything with. It'd need keying in differently and probably truing off the top, but it just gives me a bigger working platform, which, you know, let's face it, has to be an advantage. And I'll figure if it's on a decent support, the extra weight shouldn't be a huge issue. Don't know, more food for thought. These two aren't exactly inspirational. So yeah, there we go. So the original box is underneath. That's the new one. Yeah, I've actually got a vise that fits the larger box. That's my next job once I've lifted that off and the large box off, is to see whether the vise fits the small box or smaller box. That one's tidgy by comparison. I think it's 8 or 9 inches square, 10 inches when you got the saddle on. Anyway, more babbling. So that's the vise, the shape of vise that came off to the box. The scale is a 12-inch scale, and it's on there for scale, or it's a ruler. It's no, damn it, 9-inch vise, and it's going to open up what, 8 inches or something. Bigger than anything I've got, and the whole centres will pick up just about. I'll have to make some top hat collars, but they'll all pick up. So basically I bought the vise and it came with a box, so the box owes me nothing, and the vise is in reasonably good nick, and it even got a handle with it, all of which just want cleaning up. So my gut feel is ignore the larger box, stick this on, and then worry about rotating it at a later stage, because having looked at the saddle, there's plenty of meat there to stick a stud through, and then in that section there, but this is where the bolt, the threaded nut goes for the lead screw. There's not a lot of meat in there, but it's, I don't know, it's probably 5/8 of an inch thick, so how thick do you need it? But I could certainly pick up the centre of it and then stick a small flat machined recess and a hole straight through. That would give me a pivot point, but I'm actually erring on doing nothing at the moment and then having a think later on and coming back to it. Well, I've got the box cleaned up now, and that location key is actually part of the same casting, so it's been machined into it. So if I want it to rotate on that face, I'd have to machine that off, which is no big shakes, but I'm then I'm moving it a long way from original. I'm just feeling it. The top of the key is the underside. News, damn it. That hole is the forms the bottom inside section of that face. I mean, the other shaper I've got doesn't have a key to locate it. It's just got the 3 bolts in the middle, which you can see on an earlier video where I take the box off to give it a clean. What I was more bothered about was checking it over to make sure there's no cracks in it anywhere on the T-slots, and there aren't. It's the top's a bit been a bit chewed up. How the hell you do that? Oh, somebody don't give a shit. So I'll probably take a light skim cut once I've got it back on. The rest of the faces are not too bad. Doesn't look like this has been used, which doesn't surprise me. So there we go. I'm going to give it a coat of paint on the inside and do the T-slots, pick them out, and then while that lot's drying, have a think about what next. So based on that, it would give me the facility to rotate the box 360 degrees, whereas my existing shaper can do, as we found out, something like 33 degrees, but not enough to do what I wanted to do. That has the added bonus of, on the box there's one side with T-slots and one side with 2 T-slots and a V, which would be handy for holding bars on, There's another face which just got 4 mounting holes on. That might prove beneficial for mounting a dividing head, for example, if I ever had one. So that's got some merit. I'd have to pick up some bits of material for it, and then it's just a case of working out how to machine the faces on the box. I mean, given the time it would take, it probably no big deal. Do it on the mill and just take my time and get it something like. Don't fancy hand scraping them inside the box. Might prove a challenge.